Hello Year 12 and welcome to our video on ionisation energies. This is 2 lessons worth of work, so don't worry if it takes a little bit longer to make notes than it normally has. It just will save us some time in the long run. Ionisation energy is a concept you won't have met before. It didn't come up at GCSE. However, we were talking about ionisation last week when we were talking about mass spectrometry. In order to detect an element in the mass spectrometer, you need to ionise it first. So this is following on from that. So what is an ionisation energy? Well, as you know, all electrons are held in place by the attraction to the nucleus. And the ionisation energy is essentially how much energy you need in order to pull that electron away from the nucleus. The more the nucleus is pulling on the electron, the harder it is to remove. And this is a really common question in exams. So here's the standard 3-mark definition. The energy required to remove 1 mole of electrons to infinity from 1 mole of gaseous atoms to form 1 mole of gaseous positive ions. What you need to think here is, how many electrons am I removing? 1 mole. That's enough to make 1 set of positive ions from 1 mole of gaseous atoms. And you're forming 1 mole of gaseous positive ions. Sometimes they'll ask you for equations. Your equation should look like this. For sodium or for aluminium. This is for the first ionisation energy. We'll talk about other ones later. Notice that you need to write the gaseous symbol there. Okay, so what influences ionisation energy? Here we've got 3 ionisation energies for hydrogen, helium and lithium. Helium has by far and away the most and lithium the least. So first thing is nuclear charge. Helium has 2 protons in its nucleus, so it's got a much stronger pull on the electrons. The more positively charged the nucleus is, the more strongly it can hold onto an electron. However, if we look at lithium, that's got 3 positive protons in its nucleus. So why is it having such a low ionisation energy? There's 2 reasons for this. Firstly, shielding. The atoms on the lithium's got 2 shells. The first shell electrons are getting in the way of the second shell electrons, so it can't experience so much of the positive charge. It has a lower effective nuclear charge because the shielding effects mean that not so much of the nucleus charge can be felt by the electron on the outside. Also, the fact that it's got 2 shells means that lithium is bigger. If it's bigger, the electron's further away from the nucleus. If it's further away from the nucleus, there's less of a pull on it. The pull between an electron and a proton is highly influenced by the distance between the 2 of them. Think about gravity and magnetism and other forces like that, and they're always massively influenced by the distance between the 2 bodies. So, quite often you'll be asked to talk about how the first ionisation energy changes as you go across the periods. And for the moment, just for the moment, we can say that the first ionisation energy generally increases across the period. You'll notice there's a few dips, and we're going to discuss those next week. What about down groups? Well, it's quite a simple trend. As you go down a group, you have more shells, there's more shielding, there's a bigger distance to the electron from the nucleus, so therefore first ionisation energy decreases. Successive ionisation energies. So, successive ionisation energies mean that for an atom with more than 1 electron, they can lose more than 1 electron. So, for example, the second ionisation energy is the energy required to move 1 mole of electrons to infinity from 1 mole of gaseous unipositive, that means singly positively charged, to form 1 mole of gaseous dipositive, that means 2 positive charges, ions. Okay, and you can work out what it would have to be for third ionisation energy, fourth ionisation energy from this. So here are some equations to illustrate that. You've got sodium plus having an electron removed to become sodium 2 plus. Aluminium plus having an electron removed to become aluminium 2 plus. Remember, as always, to write in the gaseous symbol. So what are the trends? Well, successive ionisation energies are always greater than the previous one because you're pulling the electron away from a more positive species. There's a positive charge on the atom already, Therefore, the electron wants to stay near it more and more, the higher the positive charge. You find you'll get large increases, much larger than the trend has been, when there's a change of shell. This is because there's a decrease in shielding, a huge decrease in shielding. You've seen the effect of shielding as we go from helium to lithium, and this happens the other way as well. We can use large increases in successive ionisation energy to predict the group of an unknown element. This is quite a standard exam question. You look for the big gap. The big gap shows you how many electrons have had to be removed. So let's look at an example of this. So, in this list, there's a big jump between the second and third ionisation energies, and another between the 10th and 11th. I know it's quite hard to look at a table of numbers and work out whether there's been a big jump or not, but I suggest you look at the ratio of increase. Between the first and the second, we've basically doubled. However, between the second and third, we've times by 4. Third and fourth, we've less than doubled. Same with fourth and fifth, fifth and sixth, sixth and seventh, and so on, till we get to the 10th and the 11th, and we've times by around 3. So it's another massive increase. And that's how we can tell we've changed shell in those two situations. So that means we changed shell as we went from the second to the third electron being removed. There must be 2 electrons in the outermost shell. We then went along 8 electrons before we had another big increase, so there must be 8 in the next shell. So this tells us that this element has got 2 electrons in its outer shell, followed by 8 electrons. If we'd had all the numbers, we'd have seen that it is in fact calcium, which is a group 2 element. So that's everything for this week. Make sure you've done all the notes and the Q questions and the summaries in time for the lesson. Feel free to repeat the video if you need to. Goodbye.